Alright, Algebra 1, here we go. Get started on Chapter 3. Let that bell stop. Okay, solve and graph inequalities. We're kind of picking up where we left off because we're going to solve these just like we did the linear equations, like x plus 3 equals 5. You'll just subtract the 3 doing opposite inverse operations. Our essential question, how do you solve and graph inequalities? We solved and graphed linear equations. Now we're going to take inequalities, which are done the same way, and then the graphing is a little different, and I'll show you that as we go, but we always shade when we graph inequalities. So we're going to start out, like I said, solving like a linear equation, inverse operations to isolate the variable, get that x by itself, get everything else on the other, all the numbers on the other side. All those same rules apply that we've been doing. When you get down to the multiplying or dividing, and you multiply or divide by a negative in that last step, then you're going to flip your inequality, okay? And what I mean by flip is if it was greater than, it would become less than. Okay, we just flip the symbol, go the other way with it. Everything else stays the same, okay? When we graph a solution on the number line, and when we graph linear equations, we do it on the number line here. There's only one variable. So if you get a greater than or a less than symbol, you're going to put an open circle over that number on the number line. If you get an equal to along with that inequality, then you're going to put a solid dot. What those mean is the open circle means you can get as close to that number, like if you had x is greater than 2, you would put a circle on 2. That means you can get as close as you want to 2, but you can't equal it. Okay? And if there is an equal, like it's x is greater than or equal to 2, now by filling in the dot it means, okay, you can include that 2. You can take the 2 and everything bigger. Okay? So we'll shade the number line accordingly. So let's look at some examples. If you're graphing x is less than 3, okay, remember less than, x is on the smaller side, eat up the bigger number. So the 3 is bigger than the x, or the x is less than 3, however you want to look at it. There's no equal bar, so I put a circle on my 3, and since x is less than, I'm going to shade to the left, because that's where the smaller x's are in our number line. Remember, you think of the number line just like a ruler. X is greater than -2, put a circle on -2 and shade to the right, bigger numbers to the right. Okay? Again, you can get ever so close to -2, but you can't equal it. Okay? If you include the equal, then we just put the dot instead of the open circle. X is less than or equal to 0, put a dot on 0, shade to the left where the smaller numbers are. If x is greater than or equal to 1, a dot on 1, shading to the right where the bigger numbers are. Okay? Should be kind of a review for you. Solving some of these. Okay? X minus 15 is greater than -12. Apply all the rules that we did in the last chapter. So we want to isolate our x, get it by itself. So I'm subtracting from it, so I'm going to do the inverse operation. I'm going to add 15 to both sides. And remember, it's a number, so you're only going to add or subtract numbers from other numbers. When you do that, the 15s cancel out. You're left with x here. It's greater than, and -12 plus 15 is 3. So x is greater than 3. You want to graph it. Then we come down here. I always like to put the 0 so you have a reference. 3 is the number we're working with. There's our 3. There's not an equal, so it's an open circle. And the x is bigger than it. You're eating the x, so it's bigger. So shade to the right. Okay, take any number bigger than 3, and this would be a true statement. Like if you took 10. 10 minus 5, 15 is -5. -5 is greater than -12. Okay? If you are adding something to your x, then again, the inverse, you're going to subtract it from both sides. So it cancels here, and I get 7. I'm going to graph it. Again, I put my 0. My 7 will be out here. It's going to get a dot this time because I have an equal. And the x is on the less than side. Shade to the left. If you've got division, what's the opposite of division? We multiply. Whatever you're dividing the 3 by, that's what you want to multiply both sides by. So the 3's cancel to 1. And -2 times 3 is -6. You want to graph that. Open circle, and x is less than, so I shade to the left. Okay, pretty straightforward. Here's where you want to be careful. In order to get y by itself, To undo the multiplication, I have to divide, and when I divide by a negative, like I said in the rules on the first board, you got to flip your inequality symbol. So that cancels out to 1y. Now it's greater than or equal to, like here, I don't care if there's a negative 2 here, I multiply or divide by a positive 3. But when I multiply or divide by a negative, in this case negative 9, I've got to flip my inequality symbol. Okay? And then graph it the same. Negative 7. Y is greater than or equal to, solid dot, bigger y's go to the right. And that's it. Just remember the rules, just like we did in the last chapter, solving our equations. Just be careful if you multiply or divide by a negative in the last step to flip your inequality. Then you graph on the number line. There's one variable, so it's just one number line. Circle or a dot, depending if there's an equal to or not. And if the x's are bigger or the variable's bigger, you shade to the right. If the variable is less, then you shade to the left. And that's it. Okay? We'll take a couple days doing this in class. We'll do some application for it. And then we'll just move on like we did in the last chapter, looking at some multi-step problem solving. All the same rules apply. Okay, hopefully that's been helpful. Be ready to go tomorrow in class. See you then. Bye.